Okay, welcome friends to this video. And in this small video about the portfolio management, I'm going to look at some of the things of portfolio management which we are going to look in a non-conventional way. So what we are going to look at is how things were actually developed and what do they mean from inside. So we'll start from variance, then we'll look at how we can actually construct the efficient frontier. Then we'll look at CML, SML, and a little bit of mathematical derivations. So before I move ahead, we need to understand two things that are going to be used in this portfolio management as well as the limitation of those two things. Now, one of the constraints that we have when we study portfolio management in this part is that we only deal with linear systems. So if we look at this equation and we predict beta, what I mean by this is that if we collect all the points, and it could be following a trajectory like this, which we don't know what it would be in the real market, but we always try to fit in a linear line. So that's one limitation. Another limitation that we look here is that we use correlation, which means that we average out the distances from the mean, and we'll say that if this thing go x, or if this thing go rather 1 unit, then this thing is going to go up by mu units. If the correlation is 1, they are moving in the same direction by equal amounts. If it's -1, then they are moving in opposite direction. What we have done is that we have averaged out. So really again we are not talking about what's actually going on. If I were to take an ideal way out of the system, then what I would have actually dealt is the non-linear system. So there are new theories of neural network and all those things which are quite advanced, and time series, etc., but those are not the thing which we are going to look at. So here we are going to just look at the straight line and the equation 2 here. This is the equation of the straight line where we have used y is equal to mx plus c, and we have looked at slope. The other thing that we have used in our derivation is covariance and correlation. A small difference in that, you can check that out. So we are finding out actually the average. But in real time, when one thing moves away from the mean, this average might not be true, because it's quite naive to take the average of movements and just go in that direction. So we build an efficient frontier, and what we do in this is that we take various securities and we add them. If some moves up, the other moves down. If some moves up, the other moves a little up, and so on. So we use linear programming to get to the right answer. This linear program is again a hit and trial kind of a method, and we have various methods to do that. We'll look at how to actually build this efficient frontier using Excel in the later slides. But what we have done is that we have taken various securities and used the correlation, which is in itself something which is limited, and we have find out all what could be made using these risky securities, and we have drawn this efficient frontier. So the line that is drawn here, which intersects and goes beyond using risk-free, that's the CML. Okay, before I move ahead, let me clarify just two more things. If you were to find out the relation between movements of two securities, we can use correlation, or we can use regression, or we can use time series, or we can use more advanced adaptive models, which are neural network, case-based reasoning, etc., etc. In a very simplistic way, we use correlation here to find out, like, if one security goes up, the other goes down, and so on. So we use a very simplistic term and find out the standard deviation of the entire portfolio of those various securities. So this was something which I was talking about. Now if we were to derive beta, we are looking for the best fit. It might be possible that this line might not be the same all the ways. It might be behaving in a curvature way. We might have more accurate points, but to keep it simplistic, we find out this line. So CML is called the capital market line. It's made up of risk-free and risk-free asset. It is derived from the assumptions which we have in covariance and correlation. We minimize the covariance and correlation by adjusting the weights, going back to the equation, and so on. The next part here is this SML, and in this what we actually do is that we look for a regressed line and we search for the beta. So we search for this beta and we say that as we increase this beta, our expected return is going to increase. So here we have moved one step ahead. We are using beta, which is regression. Regression in itself has some part of linear programming and so on. So this is one level up, and we have got more detailed analysis of regression where we can find out if some things are working good or not. So that becomes more advanced. So in SML we have beta and we have return. So as we increase beta, the returns increases. So just remember this thing. So whenever we have SML, we are going to look for this regressed coefficient, which is beta. We are going to regress it with the expected return. There are some more things which I would take in the next video, because I think my time is up for this one. So I'll catch you in the next video. Thank you for watching this video, and best of luck with your preparation.